All right, class, just trying to help out with a problem here. Hopefully you can make this out. We've got find the indicated quantities for the function f of x equals 3x squared. We want the average rate of change of the function on the interval 1, 5. We want the slope of the secant line through the point 1, f of 1, and then 1 plus h, f of 1 plus h. And then we want the slope of the graph at exactly 1, and then the equation of the line through that point. So try and work through this as quickly as possible here and hit all the major points. So first of all, the function is this, and 3x squared, just double checking there. And the first part A, we want to know the slope of the secant line through the point, geez, I should probably just keep this up, when x changes from 1 to 5. So we basically want to know when x is 1, x is 5. So we have a graph here. This really isn't that relevant, but what we're trying to find is between 1 and 5, there's points on the graph, and we're trying to find the slope of the line connecting those points. So what we need here is the corresponding y values for each of these points. So I will go ahead and plug 1 in, first of all, 1 into this, and we get 3. And then over here, I'm going to plug 5 in. 5 squared is 25. 25 times 3, 75. So now we can look at these as points, ordered pairs, 575. And so the slope of a line through 2 points is going to be, let's see if I label these x1, y1, x2, y2, then we could do y2 minus y1 over x2 minus x1. Okay, y2 is 75, take away y1, which is 3, all over x2, which is 5, minus 1. So we get 72 over 4, and I'm not sure how they want that answer, so let me just check real quick. 72 over 4. Oh, duh, goes in. Okay, 72 goes in there. I'm just not thinking. It's been a long day. 1, 8, so 18. Slope of the line is 18. All right, make sure you understand where the 75 and 3 came from. They came from plugging 1 in here and then respectively plug in the 5. All right, that's for part A. Now for part B, we want to find the slope of the secant line through 1 f of 1 and then the point 1 plus h f of 1 plus h. This is where things start getting a little tricky. So instead of giving you 2 points like this, we give you one point and then a general point. So the first point is the 1 f of 1, and then the second point is 1 plus h f of 1 plus h. Now on our graph, what that's really saying, if I come back up to this graph, is that we've got our parabola, does something like this, and we're picking some point, starts at 1, and then the other point we pick is just 1 plus something. So, I don't know, somewhere out here, there's another point, and there's a line that goes through those two. It's just, I'm not telling you exactly, you know, x is 5 like we did in the first problem. That's not the case. We're just saying x here is 1 plus something. So this will give us a more general formula. So here we go. Again, labeling this x1, y1, x2, y2. Well, what we could do and should do first is let's figure this out. 1 is the x value. If we plug 1 into the function, we already know, that was done up here, that we get a 3. Now the question is, what happens when we plug 1 plus h into the function? So we need to figure out what this is, and I'm going to do that on the side. Since f of x is 3x squared, that means f of 1 plus h is 3 times 1 plus h squared. Now, order of operations forces us at this point to do exponents before we do the multiplication of the 3. So I must do 3 times 1 plus h, and I'm going to square it, so 1 plus h times itself. I will FOIL this out. Okay, then I'll have a 3 sitting here waiting for it. So I get 1 plus h plus h plus h squared. That's what I get when I FOIL. So that's 3 times 1 plus 2h plus h squared, which when you distribute the 3 is 3 plus 6h plus 3h squared. So that's what you get. Be careful. You cannot distribute the 3 first, then square. That's incorrect. That's just order of operations. We have to be careful with that. So this here is going to be 3h squared right there. Okay, so the slope of the line will be our y2, which is this piece, minus our y1, which is that piece. So it'll be 3 plus 6h plus 3h squared. We will take away from that 3, and then we will put that over x2, which is 1 plus h, minus x1, which is 1. So on the top, we get the 3's to cancel, which leaves us with just 6h plus 3h squared. On the bottom, we get the 1's to cancel, and we get h. Now, at this point, since every term has an h, we can factor an h out of the top, and then it will cancel, and what we're left with is 6 plus 3h, which represents the slope of the line connecting those 2 points. Got to do a quick pause here. I'll come back and finish this up. Okay, continuing here, what the next part of this problem. Let's see. Where is it? Uh-oh. I think I may have lost the problem. That's okay. That's okay. Oh, there it is. Okay, so now that answered part B. Now for part C. Want the slope of the graph at 1 f of 1. So the way to do this is to go back to this answer right here. Okay, and all we do is take the limit as h goes to 0 of that expression. In other words, we just let h turn into a 0, and it basically kills off this, and we're left with 6. So back on the graph, if we go to the point 1 itself and look at what the slope of the tangent line is through that point, that slope is 6. And then for the final part of the problem, we want to find the equation of the line. So this blue line right here, we want its equation. And so we use this formula, y minus y1 equals m times x minus x1. And so we need the point right here. What's our x1, y1? Well, that's the point 1 f of 1, which was the point 1, 3. We had already figured that earlier. So I know that I can replace my y1 with 3. I know I replace my x1 with 1. And my slope is exactly what we just got, 6. So that's the equation of the line. I could go further and put it in slope-intercept form. That means distribute the 6 through and then solve for y. So I'll add 3 to both sides now. There you go. So that should be the equation of the line. Let's see if the answer was in here. Where's that thing? Nope. Sorry about that. Where is it? There we go. Hold on just. Yep, there we go. Okay, that'll be it.